Good day, everyone! Welcome to Math Series where learning is fun and infinite. I am Michaella Atienza, and in this video, we are going to unlock new techniques and methods of evaluating trigonometric integrals which cannot be evaluated directly from their given forms by any of the standard formulas we've used in our previous discussion. Remember, we cannot apply product rule in the integration process, so it is necessary for us to learn new methods which can help us evaluate trigonometric integrals easier. In our previous discussion, we are done with the first 5 cases, so let us now proceed to the last 4.
So in this case, we will consider two different integrals whose conditions are the same. For the first one, we have the powers of tangents and secants. The integral of n power of tan x times m power of secant x, where n is a positive odd integer and m is an even integer, can be solved by transforming this into this form. So as you can see, we factor out secant squared x. So bakit nga ba kailangan nating ilabas si secant squared x? If you can notice, kapag dinistribute natin si n power of tan x sa loob ng quantity, we can have tan x to be our u, since its derivative is equal to secant squared x. So with that, makakancel natin si secant squared x. And dahil dyan, mas mapapadali yung integration process. So let's have the first example. Evaluate the integral of 5 power of tan x times 4 power of secant x. The first thing that we need to consider is the exponents. Is the given integral satisfy the condition under case 6? Yes, because n is odd and m is even. Let's transform this into this form. As you can see, we factor out secant squared x. By Pythagorean identity, we can have secant squared x equal to tan squared x plus 1. By distribution, we can have 7 power of tan x plus 5 power of tan x multiplied to secant squared x. We let tan x to be our u. By substitution, we can have the integral of u raised to 7 plus u raised to 5 multiplied to secant squared x du over secant squared x. So with that, we can easily cancel out secant squared x. By simple power rule, we can integrate this form. So we can have u raised to 8 over 8 plus u raised to 6 over 6 plus c. So since u is equal to tan x, with this we substitute back tan x and get 8 power of tan x over 8 plus 6 power of tan x over 6 plus c. We are done with the first integral under case 6. Let's have now the powers of cotangents and cosecants. Since we are still in case 6, the condition remains the same. So here, we just factor out cosecant squared x. If you can recall, alam natin na ang derivative ng cotangent x ay negative cosecant squared x. Let's have the first example under this case. Evaluate the integral of 3 power of cotangent x multiplied to 4 power of cotangent x dx. So still, n is odd and m is even. We factor out cosecant squared x. By Pythagorean identity again, we can have cosecant squared x equal to cotangent squared x plus 1. By distribution, we get 5 power of cotangent x plus 3 power of cotangent x multiplied to cosecant squared x dx. We let cotangent x to be our u. By substitution, we get the integral of u raised to 5 plus u raised to 3 multiplied to cosecant squared x du over negative cosecant squared x. So with that, we can cancel out cosecant squared x. Ilalabas natin si negative sign outside the integral. So, the negative integral of u raised to 5 plus u raised to 3 will be equal to, distribute na natin agad si negative sign, negative u raised to 6 over 6 minus u raised to 4 over 4 by simple power rule plus c. Since u is equal to cotangent x, we can now have 6 power of negative cotangent x over 6 minus 4 cotangent x over 4 plus c. So, ganyan lang kadali ang mag-integrate under case 6. We are done with case 6. Let's proceed to case 7 whose condition is somehow different from case 6. So, here, m and n are both odd integer. Given the same integral in case 6, we have the integral of n power of tan x times m power of secant x whose exponents are both odd. We can factor out secant x tan x. So, bakit nga ba kailangan nating ilabas si secant x tan x? If you can recall, if we let secant x to be our u, we know that its derivative will be secant x tan x. So, that's the reason kung bakit kailangan natin i-factor out si secant x tan x. Let's have the first example under this case. Evaluate the integral of 3 power of tan x times 5 power of secant x. We factor out secant x tan x. By Pythagorean identity again, tan squared x is equal to secant squared x minus 1. So we can now distribute 4 power of secant x and get 6 power of secant x minus 4 power of secant x multiplied to secant x tan x dx. We let secant x to be our u. By substitution, we get the integral of u raised to 6 minus u raised to 4 multiplied to secant x tan x du over secant x tan x. We can cancel out secant x tan x. By simple power rule, the integral of u raised to 6 minus u raised to 4 will be equal to u raised to 7 over 7 minus u raised to 5 over 5 plus c. Since u is equal to secant x, we substitute back and get 7 power of secant x over 7 minus 5 power of secant x over 5 plus c. Let us now move on to the powers of cotangents and cosecants under case 7. So still, m and n are both odd. Let us now move on to the powers of cotangents and cosecants under case 7. So still, m and n are both odd integer. Given the integral of n power of cotangent x times m power of cosecant x, similarly, we can factor out cosecant x cotangent x because if we let cosecant x to be our u, we know that its derivative will be negative cosecant x cotangent x. Let's have our example. Evaluate the integral of cotangent x times 5 power of cosecant x. We factor out cosecant x and here, we don't need to use any trigonometric identity since the exponent of cotangent x is just 1. We let cosecant x to be our u. By substitution, we get the integral of u raised to 4 times cosecant x cotangent x du over negative cosecant x cotangent x. We can cancel out cosecant x cotangent x and factor out negative 1 outside the integral. So the negative integral of u raised to 4 will be negative u raised to 5 over 5 plus c. Since u is equal to cosecant x, we now have 5 power of cosecant x over 5 plus c. So this is how we integrate trigonometric integrals whose exponents are both odd. And now let us move on to case 8. In this case, the integral contains a single trigonometric function whose exponent is greater than 2. The only condition here is that n, or the exponent, should be a positive odd integer. For instance, you have the integral of secant cube x. If you can recall, we can actually apply integration by parts. So this is the solution using integration by parts. We are not going to discuss each step. But the question is, what if the exponent gets larger? Let's say the integral of 5 power of secant x or 7 power of secant x. Can we still apply integration by parts? Yes, we can still apply integration by parts. However, mas mahaba yung process at mas complicated yung solution. So, to make the process easier, we can use power reduction formulas. These are the power reduction formulas for secants and cosecants. The proof of these formulas are not included in our discussion, but you can access them through the link pasted in the caption. Let's have the first example for the power of secants. So this is the formula for secant. Evaluate the integral of secant cube x. So ito rin yung given kanina na ginamitan natin ng integration by parts. Using the formula, we just replace n with 3. And if we simplify, we get 1/2 secant x tan x plus 1/2 the integral of secant x. And we know that the integral of secant x is just ln secant x plus tan x. So, the integral of this given is 1/2 secant x tan x plus 1/2 ln secant x plus tan x plus c. Let's have another example for secant. Evaluate the integral of 5 power of secant x. So here, tumaas yung exponent niya. Using the formula, we just replace n with 5. If we simplify, we get 1/4 of 3 power of secant x times tan x plus 3/4 of the integral of secant cube x. So, kung mapapansin nyo, meron ulit tayong integrand whose exponent is an odd. And here, using the previous example, we can just substitute secant cube x with this. So, we get 1/4 of secant cube x tan x plus 3/4 of the quantity of 1/2 secant x tan x plus 1/2 ln secant x plus tan x plus c. And we distribute 3/4 inside the quantity and get 1/4 secant cube x tan x plus 3/8 secant x tan x plus 3/8 of ln secant x plus tan x plus c. We can also use the power reduction formula for cosecant. So this is the formula. Let us try this example. Evaluate the integral of cosecant cube x. Using the formula, we just replace n with 3. And if we simplify, we get 1/2 of cosecant x cotangent x plus 1/2 the integral of cosecant x. And we know that the integral of cosecant x is just ln cosecant x minus cotangent x. So, the integral of cosecant cube x is just 1/2 cosecant x cotangent x plus 1/2 ln cosecant x minus cotangent x plus c. So, as you can see, mas mapapadali yung integration process using the power reduction formulas for secants and cosecant. Let us now proceed to the last case, which is case 9. So here, the condition is that n is a positive even integer and m is a positive odd integer. It is given in the form of n power of tan x times m power of secant x and n power of cotangent x times m power of cosecant x. If you can notice, this form is similar to case 6. The only difference is that in case 6, n is a positive odd integer and m is a positive even integer. So here, we will manipulate tan squared x and cotangent squared x. And if we can recall, tan squared x is equal to secant squared x minus 1. So here, we will manipulate tan squared x and cotangent squared x. If you can recall, tan squared x is equal to secant squared x minus 1 and cotangent squared x is equal to secant squared x minus 1 by Pythagorean identity. Let's try our example. Evaluate the integral of tan squared x times secant cube x. We transform this into this form. We express tan squared x as secant squared x minus 1. And by distribution, we get the integral of 5 power of secant x minus the integral of secant cube x. By reduction formula, from our previous example, we can now easily evaluate each term. We know that the integral of secant cube x is just equal to 1/2 secant x tan x plus 1/2 ln secant x plus tan x plus c, and the integral of 5 power of secant x is just 1/4 of secant cube x tan x plus 3/8 of secant x tan x plus 3/8 of ln secant x plus tan x plus c. We replace 5 power of secant x minus secant cube x with their integrals. And if we simplify, we get 1/4 of secant cube x tan x plus 3/8 secant x tan x plus 3/8 ln secant x plus tan x minus 1/2 secant x tan x minus 1/2 ln secant x plus tan x. Combining like terms, we get 1/4 secant cube x tan x minus 1/8 secant x tan x minus 1/8 ln secant x plus tan x plus c. So, kahit gaano pa ka-complicated ang trigonometric integral, we can easily manipulate them and transform them into forms that are easier to integrate.
These are some of the examples you can try in order to apply what you've learned in our discussion. You can use Simulab or Photomath to check your answers. So, that's all for this lesson. This is Michaella Atienza. Thank you for listening and see you next time.